let me introduce our moderator, Dr. Irving Wladawsky-Berger. Retired from IBM in May 2007, 37 years in the IBM company. He's the chairman emeritus of the Academy of Technology for IBM. Right now he's spending his time as a visiting professor at Imperial College at MIT. Did some seminal work for us in the Linux and Internet initiatives. With that, I'm going to turn it right over to you, Irving.
Okay, thank you. And first, it's a pleasure for me to be back in Yorktown since I spent the first 15 years of my career right here until in 1985, I was sent out either to spread the word or to get out of here. I'm not totally sure, but it was interesting. So let me bring my fellow panelists, Eric Cruz, Consumer Marketing Strategy, Senior Expert in Consumer Behavior and Network Society Evangelist at Ericsson. David Aronoff, General Partner at Flying Bridge Venture Capital Partners, an investor in a variety of technology companies. Ashifi Gogo, the CEO of Sproxel, which is a VC-backed enterprise that delivers supply chain consulting services to pharmaceutical companies. And Jim Schatz, who worked at NSA from 1979 to 2009, and is now head of the Research and Exploratory and Development Lab at the Applied Information Sciences of Johns Hopkins University. So what we're going to do is, let me ask each of you, starting with you, Eric, to talk about your grand challenge. Let me ask you all to do that as briefly as possible so we have time for discussions. I want to add my 2 cents in, so I'll talk about my grand challenge, and then we'll have a discussion and we'll involve the audience, okay?
Okay.
So Eric, you're on.
Thank you. First of all, I want to warn you, I don't know anything about computation. I'm a social scientist. I work for Ericsson that makes infrastructure. And first of all, I want to thank you to invite me. We had a similar event 35 years ago. I had to take that. I look on consumer behavior and business behavior and a little bit about technology, even if I don't understand it. But I think we are on a brink of a new society where we need to rethink how we think about the next grand challenge. Today, thanks to computing and mobile technology, we have empowered people. We have empowered consumers that share more information, that generates more data, and are connected more or less 24/7. And now we have a big driving force called digital natives that are coming out into the business. And digital natives, of course, they have been grown up with digital technology, internet, and mobile telephony as a natural part of their life. And they have different expectations and a different mindset. And I want to share you a true story. I have a son that is 14 years old. 3 years ago, we were driving to my mother. It's a 4-hour drive. He was 11, sitting in the backseat of a car, and after 30 minutes, he was picking up his Nintendo DS and started to press buttons. And then he sighed, and then he said, "Daddy, where is the Wi-Fi?" And I said, "Son, are you stupid or what? We don't have Wi-Fi in the car." And then he said this, "Daddy, you're working for Ericsson, and you don't have Wi-Fi in the car." And then he handed, "You're such a loser." Because he could not understand why the hell couldn't he have a conversation or a chat and networked games with his friends in the car, because he can have it at home, he can have it at airports, train stations, McDonald's, etc. So we have a generation that has a different mindset. They expect to be connected. They expect more or less to have any service on any device, and that will act as a change catalyst and set new rules for what is the next grand challenge. Then we also have changing business, where now businesses are looking for how can we connect our offerings so it suits the consumers and also make their processes more efficient. With the vision of 50 billion connected devices, with how can we network, how can we offer new types of digital over-the-top services when we have connected devices, connected medicine boxes, connected TVs, etc. And then we have the enabling technology. Today, 85% of the world's population has coverage by voice and data. And we have some 5.5 billion mobile subscriptions. People are sending 200,000 text messages every second, 24/7. That ends up with 6.1 trillion text messages every year. So we think truly that these three forces now are working together, where we see a new society emerges. Just thinking about now, we have Neil talked about the Internet of Things, but I think we see waves where consumer electronics now, due to digital natives and so on, are becoming networked. We get lots of data, and we also get businesses that wondering what should we do with the data? How can we get information about it? And that is, of course, good for IBM, since you're working with analytics. Networked verticals and industries, and then our vision is that more or less everything will be networked and can provide data and can also be smarter. And I think that is something that opens up for new opportunities for computing and for our own industry. The interaction infrastructure with broadband, mobility, and cloud, and lots of enablers. I think that more or less everything converges towards broadband. We will use broadband to deliver services to the citizens. We will also have broadband where they consume services from societal infrastructures. And there we see that we can address the global challenges. And I was thinking about what should I say as the grand challenge for computing in IBM, and then I got depressed this morning because I got this in my welcome package, because I thought that we have an opportunity now. We have a smarter society or a network society. Then we should address the global challenges. To not, you have played chess, you have played Jeopardy. What's the next? American Idol? No, I don't think so. I think really that we should address climate questions, aging population, scarce resources like water, power, and raw material. Because now we have a supercomputer more or less in our pockets. We can use that to both extract data that supports the global challenges, but also we can use this screen to support the end user with information that they can make real decisions. If I lower the temperature with 2 degrees in my home, how much money will I save, and how much will I save the climate? Because I think now we have a responsibility to actually address the global challenges, and that, I think, is the real challenge. But you have already started with everything, so congratulations.
So you mean we're doing it so...
You're starting with it, but I think we need to have it on a global scale, and also we need to have a system where we include everyone. So we need better
So I'll ask
user
you
interfaces.
later. We want to hear from Dave, but I wanted to ask you, what are some of the key challenges you think we need to do to make it all happen? So David, you're going to tell us about the green data centers and green computers, right?
I'm going to try to. You know, I'm reminded that every time I do have the chance to spend time with Neil, and I'm reminded of how narrow-minded I am every time I get done hearing Neil speak. Because I have a great job. Having been at Bell Labs probably around the same time that Neil was, I ventured into the startup world afterward and have been a venture capitalist for the past 16 years, backing the dreams of really smart people. But because my investors give me money with a horizon that's probably 8 to 10 years, that I think is what qualifies me as being narrow-minded, Neil. So I'm apologizing to the professor. In thinking about the grand challenge, therefore, I started thinking about the things that IBM has done in the past with Watson or Deep Blue or Blue Gene, and in thinking about also the fact that IBM is the eco-friendly company, really having focused on smarter cities and the smarter world. I tried to apply that toward the notion of computing in a way that would actually make sense for a venture capitalist to think about investing in it. And with that, my challenge, to be specific, is for IBM to build a high-performance, price-competitive, and performance-competitive data center class server. It could be, you could take that adjective and use anything you want, that operates in a carbon-neutral footprint. So to be true citizens of the world to build something which, while providing the compute power, unfortunately, Neil, probably in a more digital, kind of forlorn way to the way things are done today, but really consuming no more power than it needs to, and recovering it. I also thought about some extra credit questions for IBM, though, because I thought maybe that would be too easy in the next 5 years. So the first extra credit question is to do it in a way such that the components are recyclable, and that the process actually for building it would be eco-safe and carbon neutral. And wondering if that was enough, Irving, I thought about the notion of, well, to do it in a place where it would be hardest to do it, so to build it in the United States, where the cost of labor is such.
Well, you are tough.
Yes, so it's a three-part challenge, and
next you'll want John Kelly to go to Congress to get the money from Congress.
Well, if I was good, having been spending time with Neil on digital fabrication, I should have said that it built itself, but that would be in the next 20 years, I guess.
Yeah. Actually, something that goes through my mind, and other people can say, is whether some of the things we need to do for exascale anyway start getting us in this direction, because power consumption is so much the key thing. So maybe it will be a natural corollary of exascale, but maybe we can discuss that later. Now, Ashish, you'll talk to us about IT and emerging economies, correct?
Sure, yeah. So my name is Ashish Gogo. I work for a company called Sproxel, which won the IBM Smart Camp competition last year and placed second at the Globals in Ireland. I don't have any slides, I'm just going to pass this on to you. So very quickly, what Sproxel does is we put item unique tags onto pharmaceutical products, so that consumers around the world can verify their products to avoid purchasing fake pharmaceuticals, which injure people year in and out. It's about a $200 billion problem that we're addressing, and we're venture-backed out of Cambridge. So my grand challenge stems from the experience that we've got in managing logistics around very fragmented supply chains. In developing nations specifically, it's sort of a big noodle to go from manufacturer to end consumer, and that's where counterfeits come in. And more importantly, there is very little consumer feedback that comes from the consumer back to the manufacturer. Here in the US, when you use your loyalty cards to get those fake discounts at the stores, because they just mark up the prices of the items that don't require the loyalty card. Sorry. That's fine. When you use your barcoded discount loyalty card, you're actually providing information back to the manufacturer. Companies aggregate that information, and then that goes into marketing decisions and so on. There's about 2 billion people left out of that process who also consume products, who don't have the means to feed information back to...
2 billion?
Yes, 2 billion to consumers. And that's due to lack of point-of-sale systems, low income, low literacy, and so on. But these are some of the markets where there's large growth that's coming out of consumers, of the new middle class globally. So the challenge would be to figure out how to get reverse logistics working in environments that have basically inconsistent power and low infrastructure. One of the ways in which we're beginning, and by no means can we solve this alone, is to empower people to use their cell phones to be able to transmit feedback back in a scalable way. So it'll be interesting to see how IBM can leverage crowdsourcing to be able to get sort of consumers on the fringes of countries that have good infrastructure to be able to provide reverse logistics or feedback that would go into manufacturers who make these products, so that overall there's a feedback loop that optimizes the production of resources, which I guess eventually would become part of the material if you have your.
So it's include in the marketing research data the 2 billion people that are sort of joining the world's economy. Is that a good way to say that?
And to some extent, adding an electronic record to cash-based transactions.
Okay, and let me ask you, one of the most fascinating projects that's going on is, I think of it, the transition to mobile digital money. That is where your digital wallet is in your mobile phone. And I wonder if that would be the vehicle. Oh, and as you know very well, mobile phones have stopped the digital divide. They are prevalent around the world. So I wonder if when that transition happens more and more, that will be the vehicle to start gathering all that data so we can implement what you are talking about.
That could be very interesting. I think if you look at the countries where mobile banking has taken off, you could pretty much list them on one hand, right? It's Kenya and a couple of countries in Asia Pac. And by and large, it hasn't spread as much because I think there's a cultural disconnect between counting out cash and then going on your mobile phone and going through 5, 6 menus just to transfer some money. So I think, interestingly, if we could have a more physical equivalent of transferring value of your mobile phone, maybe through bumping your phone to another,
okay.
That may be a good way.
That would be an interesting discussion. What's the carrier for doing that work? And then, Jim, you'll tell us about applications in pure math and theorem proving.
First of all, it's an honor to be here to be part of your centennial celebration, John. My father had spent his professional career at IBM, and I grew up in Poughkeepsie, which will resonate with some of you. And he had a little hand in doing something called time sharing on a mainframe computer.
We know about that.
Anyway, my challenge today for IBM Research is to put together a complete proof, a formal proof of Fermat's last theorem. What's that about? Well, right now there's a quiet revolution going on in mathematics in this realm of formal proofs. And these formal proofs right now are essentially verifications of the major theorems of mathematics. So there are formal proofs now of the prime number theorem, of the law of quadratic reciprocity, four-color theorem, fundamental theorem of calculus, fundamental theorem of algebra. And what you do in one of these is you use something called a proof assistant, which is something like a programming language. And the goal here is to do a complete review of that proof from the very first simplest axioms that define mathematics right down to the complete statement and proof of this theorem. So imagine this. John goes down the road to Armonk and says to the top brass at IBM, we're going to put $1 billion into a verification of the proof of Fermat's last theorem. Pretty sure they'll say, in the history of IBM Research, John, that's the dumbest idea we ever heard. Has Wellspring asked us for that? So this is what John needs to say at that point. He needs to say, this is step one. Right now, it takes a week to take a page of an undergraduate math textbook and work it into a formal proof. The size of one of these formal proofs is about 4 times the size of the math written down on the page, so it's not a big expansion factor. But a week to do 1 page. So part of this challenge is to come up with a optimized proof assistant, which is the language of doing these proofs. And, oh, by the way, before Neil gets rid of these von Neumann computers, remember, they were designed to do mathematics. So let's get one of these exascale computers working on this and stop asking our computers to answer questions about Toronto. But the point is, this is step one in a big program. The real point here is, the next thing you're going to talk about is, can the computer come up with the proof, not just verify a proof? So the state of the art on that right now is, if you think of undergraduate math, homework problems, computers can now do the proofs of those on their own. And up to the point where showing that the number e, the base of the natural logarithms, is an irrational number, that can be done automatically by a computer. But where we're really going here is we need the computers to generate new theorems and to verify those theorems. Right now, there's some pretty interesting conjectures in graph theory that the computers have generated all on their own. Where you're going with this is the fully automated mathematician. Because as much as we love technology, and nobody does technology better than IBM, don't forget the greatest achievement in humanity is mathematics. And you can take this. There's no other research organization in the world besides IBM Research who could take automated theorem proving and automated mathematics to that higher level. And I think you start out with a goal of a proof verification. But what you're going to find out, and I'll sit down after this, is in 1901 at the International Congress of Mathematicians, Hilbert got up and gave us 23 problems. And what he really talked about in his speech, though, was the need for rigorous mathematics. Because what you're going to find here is that all the ideas in mathematics that you're going to want to generate are going to come from making those proofs rigorous. Any mathematician will tell you that the process of writing the paper is when they got all the new ideas. And that's what's going to happen here is the more you can drive that thing down into an automated system, there will be an explosion of mathematics come out of this. And this is really, I would say, this is the new revolution in mathematics. You had Euclid's Elements was step one. You had the rigorization of mathematics in the sort of 19th century with Cauchy and those guys, Weierstrass. This is the next stage in the revolution of mathematics, and the implications of this for humanity are going to be profound. So that's my challenge for IBM Research.
Jim, I love the image of John going to see San Palmisano.
You think you can sell that now, John?
And saying, I want $1 billion to prove Fermat's last. I love that image. But seriously, to help John make that case, what would be some applications to business and society were we able to do that? What you said it would help humanity a lot. Give us an example or two of what that would be.
Can't, and I'll tell you why. There's something I call the law of conservation of energy in mathematics, and that is that every bit of mathematics ever invented has been applied. Hardy used to be so proud of the fact that number theory was absolutely untainted by the real world, and cryptographers showed, unfortunately, didn't live long enough to see that. I will tell you that mathematics is going to, the mathematics that will come out of this is going to revolutionize everything else we do, because it's going to be the thing that gets us past our limitations in computing and everything else. One great math idea can eliminate $1 billion worth of computing. And so the applications here, you're going to have to trust me on this one. If we build it, they'll come. Okay. Thank you.
Okay, and I'd like to briefly put my 2 cents in on a grand challenge, which is something I've been thinking about, and I've talked to Bill LaFontaine and John Kelly and discussed with Dave Ferrucci. And I think there is no question that we are living in an increasingly connected, complex, and unpredictable world. I think lots of what's going on in the world is pretty much emergent. And so the question is, if you need to make decisions, you need to find out what's going on, you need to perform many management kinds of activities, how do you do that in a world that is so unpredictable, where you cannot tell with precision what will happen? Well, we know the answers because we kept hearing it through the day-to-day, which is you take a more statistical approach. And John talked about it, and Dave Ferrucci talked about it, and I think that was implicit in a lot of what Steve talked about. Now, that's not new. And in fact, this really goes back now to my youth. I studied physics at the University of Chicago, and you remember there was a major revolution in physics about 100 years ago when we sort of went from classical mechanics to quantum mechanics, and where physicists had to learn to deal not with a deterministic world in classical mechanics, but with a statistical world. And that was difficult even for physicists. And I think Einstein famously said at some point that God doesn't play dice with the universe. Am I correct? There is some such phrase that Einstein said, So if even Einstein had trouble with concepts like the uncertainty principle and so on. So if more and more in business and society, we need to learn to manage and make decisions in a more statistical world, how do we train people? How do you educate people? Do we need new kinds of disciplines or extensions of information and management systems? Certainly business schools don't do that. And then you get things like financial crisis and so on that nobody anticipated because they were thinking in the old world, not the new world. So the grand challenge, John, is there is a lot going on already in these areas. Is there something we should do to put our arms around it and sort of formalize this transition from a more deterministic, let me use the term management and decision world, to one that will be more based on leveraging tools like Watson, leveraging tools like ensemble computing in modeling and simulation, and similar such tools to help us make such decisions. And I don't think that will be so easy, and it will probably take quite a bit of education. So that's my thought. Jim, you got a question over the system. So why don't we start with that question?
The question has to do with whether it's time to relinquish our control for high precision and allow in our electronic circuits in our computing, and allow for greater unreliability in order that we can give up this desperate need for power in all the modern computers. And would such a paradigm be acceptable, and what sort of software and algorithms would be required to do that? This is from Drew Vandeth, a friend of mine who's now at IBM. And my answer, Drew, is that'd be a great question for Neil to tackle at some point. My comment would be, as we think about computers that are more capable of modeling the neurons and so forth, which is what we're feeling the von Neumann architectures maybe aren't, there's probably going to be an element of approximation in the kind of calculations we do. And so I could easily see a computing paradigm where we give up a little bit in accuracy and gain a whole lot in terms of low power, which is, I think, what the 20 watts usually gets us. As David pointed out this morning, it's not so amazing that computers play chess, it's amazing that humans play chess.
Okay. But let me ask a follow-on question to that, which is, and again, one of the things that I know my colleagues in IBM research have been doing is there isn't just one kind of architecture. Different kinds of applications require different architecture. So let me assume that for managing bank accounts, transaction processing, you want a very deterministic computer that always works the same way. But maybe for some of the more Watson-like analytic applications, the ones where it's going to be more stochastic anyway, if giving up some of those precisions could save power. Right. So it doesn't have to be all or nothing. It could be for certain applications. And I don't know if we already have things like that going on or not, but that's a very interesting idea of trading it off for applications where it's okay to do that. David, one question about green that I think has been very in everyone's mind is, and Ashifi mentioned, there are more and more people joining the world's economy, and we sold the American dream. They say, great, I want in, but boy, if they consume energy like Americans, it's all over. So I wonder if there are some gigantic implications to some of the sustainability things you're doing that we must do anyway to absorb the people now coming from emerging economies whose standard of living is rising.
Well, I think so, but one of the problems that we see around the world right now, and I have the benefit of just seeing a lot of startup companies with similar ideas, and to watch as they ebb and flow and to see the success or failure of them. And there's been a huge rush around green IT for the past 5 or 6 years. And one of the things we've noticed is that it's largely aspirational. It's kind of a shame, but it's largely aspirational, with the exception of a few economies where regulation enforces it. So in Germany and Scandinavia, you see it more than just kind of doing the good corporate citizen thing. Where here in the U.S., I think it's largely a PR thing, unfortunately. So the alternate to it, I know it sounds like a pretty pessimistic view, but this is why I kind of said I had the challenge, I placed it the way I did. I think that where there is payback and where it's automatic to see it, instant gratification, that's when the notion of being eco-friendly seems to work. Yeah. And so I think in these new economies, the challenge is, can that be embedded from the start? And I think we are seeing it in China.
No, I understand, but Ashifi, as a follow-on to that question, I have a feeling that as the standard of living goes up and people start consuming more energy, eating more beef, more electricity, all these things, sustainability is survival for the planet. In other words, forget whether you believe in science or climate modeling, or you could be the most extreme of whatever people who don't believe in science running for president are. But at some point, if we don't have enough energy to take care of everybody, we don't have it. And going to tell people in Africa, India, China, can you wait a few decades before we do that?
Yeah.
So am I right? There are huge implications here with emerging economy standard of living coming up, right?
Yes, they are. And one of the ways in which to make what we have work for us, even though there are more people trying to access the pie, is to minimize waste, right? There's a lot of waste.
Which is what Neil talked quite a bit about that.
Yeah. There's a lot of waste in the system that comes from lack of knowledge of preferences. And by establishing basically a database or a means by which preferences can be established in good time to minimize waste, you could go a little farther along with the limited resources that exist today.
Yeah, well, which gets us back to a smarter planet, because at some level, you would hope that that's what happens in a smarter planet. And do you see that in a more networked society, part of the ways we use information is sort of one way or another optimize our use of resources or do that in a more distributed way?
I think we have the possibility to do that.
But that's the grand challenge.
Absolutely.
Is what do we do?
And also, I think that's why I love your challenge, because we Western countries cannot ask high growth markets to wait. We need to change. Yeah. We need to lower our energy consumption. We cannot ask others to wait.
Yeah.
And I think that is, since I'm naive in computing, I can be positive and see the opportunities. I think we have a huge opportunity to actually leave the state of the planet in a better shape to our kids than it is today. But then we need to change our mindset and see the opportunities.
Yeah. Let me turn to the audience. Please, over there. And Bill, you'll tell me when I'm done, okay? But I started late, Bill.
You're the only thing between them and reception.
I understand.
You better go quick. Jim Myers from RPI. More of a comment than a question, but I hear a common theme across these that I'll sort of twist your slogan and say, excuse me, that the grand challenge really should be to develop a smarter planet that makes the planet smarter. And I think what I want to get through that is, right, when we have a network society, if we don't get the people at the end of the nodes to understand what the implications of their actions are, we're not going to get there. We're not going to get greener. If people don't have the information back on the edges, the marketers are going to do more and more magic and pull power away from the people who need to make choices on the edges of the network. And I think in your comments were the same way. You know, that we're really having to educate a new set of people who have to understand this stuff. So I think there's a danger in the smarter planet of along the lines of centralizing the intelligence, as Neil was saying. Right, you could do this the wrong way, and you could really make you could really make it hard to get the information out and to really change the world this way. So turn your slogan around on itself, and I think you've got the right challenge.
Mm-hmm, mm-hmm. Yeah. You're saying the key to a smarter planet may very well be empowered individuals collaborating to make the planet smarter. Yeah, no, we agree totally with that.
I wanted to help build John's case for the $1 billion. This is Tim Lance from Nisonet. The Fermat problem is solved in one sense, but we really don't understand the solution. It involves only 2 primes, even though it gives information about every prime, and it gives information about geometry in every dimension. It's the kind of problem that IBM takes on that's big enough that the outcomes have unexpected returns. I think the brilliance of Watson was that it was a problem everyone could understand, and in their gut they knew it was hard. And so solving it had a tremendous public return as well as the technical challenge. But the equivalent of what you're doing that also has that social impact says now there's support behind it.